You ever just stare at a spreadsheet packed with numbers and wonder, what is this all trying to tell me? Well, here's the thing. Data is always telling a story, but you need the right tools to actually read it. Today, we're going to unlock two of the most powerful tools in statistics, and I promise, by the end of this, you'll know exactly which one to use and when. Let's get into it. Okay, let's make this super simple. Imagine you're a teacher, and you've just finished grading a huge test. You've got all those scores right there in front of you. Now, looking at all that data, what are the first questions that pop into your head? Well, the first, most obvious question is about the group you know everything about, right? How did this class do? You want to know exactly how this specific group of students performed on this one test. No guesswork, just the plain and simple facts. But then you start thinking about the future, and that leads to a totally different kind of question. How will next year's class do? All of a sudden, you're trying to use what you know about this class to predict something about a group you have zero data on. And these two questions, they perfectly set the stage for our two types of statistic. So first up, let's deal with that first question. To understand the data you have sitting right in front of you, you need to step into the world of descriptive statistics. Honestly, the name says it all. Descriptive statistics is all about describing what you see. It's about taking this big, messy pile of data and making it super easy to understand by, summarizing it and organizing it. It's all about answering the question, what is happening? And that's the key thing to remember. Its whole purpose is just to describe. That's it. It doesn't make predictions. It doesn't guess about other groups. It just says, for example, the average grade of your class is 85. Period. End of story. And this right here, this shows it perfectly. You can calculate the average score, which is 85. You can spot the highest score, a perfect 100, and find the lowest, a 60. These are just hard, cold facts about this class. We're not saying anything about any other classes. We're just describing the one we measured. Okay, now let's jump over to our second question. What if you want to use your data to make a really smart, educated guess about a group you haven't measured? Well, for that, you need the power of inferential statistics. So, inferential statistics is all about taking a small piece of data, we call that a sample, and using it to infer something about a way bigger group, the population. It's really the art of going from the known to the unknown. I absolutely love this way of putting it. It's not about just, throwing a guess out there and hoping for the best. It's about making smart guesses. You're actually using math to make a logical leap from a little bit of info to a big picture conclusion. You can pretty much break its job down into three main things. You can generalize, like saying most students in the whole school probably feel a certain way based on one class. You can predict, like guessing next year's class will also find a topic difficult. Or you can estimate, which is a really, really powerful tool. An estimation is a huge one. Just imagine a school with 500 students. You want to know how much they all spend on snacks, but asking every single one would take forever. So what do? You take a sample. You just ask 50 of them. And if that small group of 50 students spends, say, an average of 50 pesos each, you can then estimate that the grand total for all 500 students is somewhere around 25,000 pesos. Did you see what just happened there? You just used a tiny sample to infer a huge number for the entire population. That's the magic of it. Okay, so we've met our two main players. Now it's time for the main event, right? The head-to-head showdown. Let's put them side by side to make the differences totally crystal clear. So, we're going to build this comparison table out piece by piece. Let's start with the most basic thing. What do they even mean? Okay, on the left, you've got descriptive, which just summarizes and organizes stuff. But on the right, you've got inferential, which takes that big next step. It makes those generalizations, those predictions. So you see, one is all about organizing and the other is about concluding. And that flows right into their purpose. Descriptive stats, their goal is to tell you what the data is. Inferential stats, their goal is to tell you what that data means for a much bigger group. It's just like our two questions from the beginning, describing this class versus predicting what next year's class might do. And of course, they use totally different toolkits to get the job done. Descriptive uses really straightforward tools we all know, like mean, median, mode, and visuals, like charts and graphs. But inferential? It brings out the heavy machinery, like hypothesis testing and regression, to make those smart guesses with some level of confidence. So let's wrap this up with the clearest example. The average grade of your class is 85. That's a descriptive fact.
it is what it is. But saying, based on this sample, we estimate the average for all 100 students is probably around 83, that's an inference. You see the massive difference? One is a certainty about a small group, the other is a calculated guess about a much, much larger one.
Now, it's super important to remember that both of these powerful methods are totally useless without one thing: good data. So how do we even get that information to begin with? Let's do a real quick look. So there are basically 5 main ways to grab the data you need. You can do an interview, just talking to someone directly. You can use questionnaires, like sending out a survey. You could try observation, just watching what people do. You could run an experiment where you actually test something, or you can do a record review, just digging through existing documents. The real key, though, is that the method you pick has to match the question you're trying to answer.
All right, we have covered a ton of ground. We've defined the 2 big branches of statistics, we've seen them in action, and we've put them head to head. So, what's the one single thing you absolutely have to remember from all this? It all boils down to this, right here. The statistical tool you reach for completely depends on the question you need to answer. Are you just trying to describe a situation that's already happened? What is? That's descriptive. Or are you trying to use that info to predict or guess what could be? Well, that's inferential.
So the very next time you're looking at a bunch of numbers, doesn't matter if it's sales figures or sports scores or lab results, the first thing to ask yourself isn't what's the average. The first question is, what am I trying to figure out here? What question is this data trying to answer? Your answer to that will tell you exactly where to start. Thanks for sticking with me.